Chapter 11, Analysis of Variant or ANOVA procedure. In this chapter, you will learn to 1. Test for a difference between the mean of 3 or more population using one-way ANOVA. 2. Test for a difference between the mean of 3 or more population with a blocking factors using randomized block ANOVA. 3. Understand the benefit of incorporating a blocking factor with analysis of variance. 4. Examine the effect two factors have on the mean of 3 or more population using two-way ANOVA. 5. Test for the interaction between the two main factors with two-way ANOVA. 6. Perform multiple comparison tests for all three ANOVA techniques. Chapter 11 consists of 11.1 One-way ANOVA, 11.2 Randomized block ANOVA, 11.3 Two-way ANOVA. In Chapter 9, we learn how to perform a hypothesis test to estimate a single population parameter such as a mean or a proportion. Chapter 10 extended this concept to estimate the difference between two population parameters. This chapter will take hypothesis testing an additional step by comparing 3 or more population means using a technique known as the analysis of variance or ANOVA. This procedure is so special that it even has its own acronym, ANOVA. This technique has many useful business applications, such as determining the following. 1. If the average amount of time spent per month on Facebook differs between each group. 2. If the average airfare for round-trip flight from Philadelphia to Paris differs between airlines. 3. If the average number of sales calls per day differs between sales representatives. The analysis of variance technique comes in 3 different flavors, which are known as design. Each design organizes the data in a manner conducive to the type of analysis that is desired. The designs are as follows. One-way ANOVA. The one-way ANOVA design is the simplest of the 3 designs and compares the mean of different levels of one factors. For example, comparing the satisfaction level of 4 different smartphone brands is an example of this procedure. Randomized block ANOVA. The randomized block ANOVA design is a variation of the one-way ANOVA where we use matched samples in a similar way to the matched pair in Chapter 10. For example, suppose we believe that the size of the monthly smartphone bill influences the satisfaction score. We could then group customers with similar bills together within each brand. This design will allow us to block out the variation in score due to the size of the bill for each brand. Doing so may allow us to detect differences in satisfaction scores between brands that may not be evident if we had used the one-way ANOVA design. Two-way ANOVA. The two-way ANOVA design compares the mean from different levels using 2 vectors. For example, These methods allow us to look for differences in satisfaction scores between smartphone brands, the first factors, and differences in satisfaction score between education level of the user, the second factors, simultaneously. Each of these procedures relies on the following set of assumptions. 1. Each of the population being compared follow the normal probability distribution. 2. The observation must be independent on one another. 3. The population being compared have equal variances. 3. The observation are either interval or ratio data.